All right, guys, here's our video for Unit 10A Part 2. So 10A Part 2, we're gonna have the notes uploaded. And again, this is gonna be something that you're probably gonna be seeing this video after spring break because that's when I'm gonna be uploading it. But I'm here the same day as I did 10A Part 1. Okay, so for Part 2, what we're doing is we want to identify trig ratios using right triangles. So our trig ratios, and you'll hear me say trig ratio or trig function, trigonometric functions. There's 3 of them, and we're gonna get real comfortable with these over the course of this unit. So they are sine, cosine, and tangent, okay? And what we do with these is we figure out, kind of like what we did last time where we had different side lengths and we used the Pythagorean theorem to come up with different variables that we didn't have. This is just like a new set of tools to come up with different variables and different ratios between right triangles, okay? So I've drawn a right triangle here, and we're gonna figure out sort of how to utilize each of these 3 ratios to just figure out how they relate for this angle and we'll kind of go from there, okay? So to start out, what we really want to look at here is we want to label each of these side lengths. I'm not gonna give these numbers. We want to be thinking of these as either hypotenuse, which we should already know, so we'll start there. Hypotenuse is always across from the right angle. So it's across from here, that means this is our hypotenuse. This will be HYP, okay? Notice that each of these trig ratios, or these 2, has an H in it, so let's keep that in mind, all right? Okay, so the second one we're gonna try to visualize here, this is gonna be our opposite angle, or I shouldn't say our opposite angle, our opposite side length, actually. And when I say opposite, really what I'm thinking of is it's the angle, or it's the side length that is opposite from our angle right here, okay? So I see that the angle, and if I've defined theta, that's what I'm gonna call this, is angle theta. And if I go straight across, that's our opposite angle, okay? So this is opposite, OPP. Y'all know what OPP? Yeah, you know me. I know. Okay, so that leaves one more. And before we get on to that last one, let's see opposite. We've got an O here and an O here, so that's gonna be relevant. So then our last one is gonna have to do with the A, and that's gonna be the adjacent side length. Okay, so that's gonna be the one that we sort of fill in. Adjacent was, I think for me, the hardest one to sort of wrap my head around when I first learned this. And it'll be the adjacent side length. And the way that it helped me think about it is that when I have an angle right here, there's only 2 lines that kind of make that angle. One of them is the hypotenuse, and that's the first one we'll identify with every problem, and that's right here. So the other one has to be adjacent, and adjacent really means like next to the angle, okay? So like the adjacent side length right here is the one that's next to the angle that is not the hypotenuse. Okay, and so we can also sort of visualize how these 2 go together, because this angle, opposite is just straight across, and adjacent is right next to the angle. Okay, so this is kind of how we've got to be thinking about all this stuff as we're going through these problems. Okay, so I grabbed the wrong note sheet. I'm right here. All right, so now we're gonna go back to what we've got up here. So sine, cosine, and tangent. And what we wanna really remember here is this phrase, SOHCAHTOA, SOHCAHTOA. And I always think about it as like, I don't know if you've ever watched like a rugby game and they do like the haka before, and they do all those like, SOHCAHTOA. I don't know, that's just how I think about it. It's kind of helped me over the years. But what we're gonna be doing here is we're gonna use each of these three trig functions gives a ratio that has to do with each of these 3 side lengths, okay? So we'll start with sine, and that's the SO, S-O-H. And what this means is that the sine of the angle theta, so sine of theta equals O over H. So opposite divided by hypotenuse, okay? So op, O-P-P, yeah, you know me, over H-Y-P, okay? And that's kind of what we can see right here at the top of the note sheet. I'm just sort of explaining what each of these are, okay? And we're going to get into these examples with numbers, but for now we just want to define them with our ideas here, okay? So our next one is cosine. So cosine of theta, well, what do you think A is, you guys? A is going to be adjacent. So ADJ over HYP, adjacent over hypotenuse. Okay, so if I was asking you to find the sine or the cosine of theta, you would be doing whatever number's here for adjacent divided by the hypotenuse. That would give you cosine of theta, okay? So our last one is the only one that doesn't have to do with the hypotenuse, and this is that tangent of theta equals opposite, OPP, over adjacent. Okay, so we would take the opposite side length divided by the adjacent side length, and that would give us tangent of theta. Okay, and so what's tricky with this is that with what we're learning today, we don't really get like a ton of useful information out of it for like real world applications, but we're really just trying to visualize like the ratios here, okay? Because in the next lessons and as we get further on in the unit, you're gonna understand why we're doing this, but for now, the big key is like the purpose of today's lesson is to just get the ratios based on what is being asked with these things, okay? So I will now go into these examples, the two examples at the bottom, okay? So I'm going to erase all this, and again, this is all in the notes, so we don't really need to think about it too much. I basically copied down the same triangle that's in the notes, and we just went from there, okay? Because yeah, the cool thing about this and how it relates to engineering is because you'll have like different diagrams of like forces acting on things and like trying to push it, and you've got like friction, all these things resisting, and you need to work out like all the angles using sine, cosine, and tangent to try to figure out like, I don't know, just engineering stuff. There's all kinds of different cool engineering stuff. How to figure out how to make your robot work, how to make sure your beams are like adequately sized, all that kind of stuff, okay? So I'm gonna jump into this example right here. This first example on the lower left side of the page. Okay, so I've got 10, I've got 24, and I've got 26. Okay, so when I'm starting to look at a problem like this, there's two things I want to identify for sure. The first one goes back to what we talked about in 10A part 1, and that's going to be where the right angle is. And right here, we can see that it's this one, lower left. It's not actually labeled on the paper, but we can see that that's what it is, just by kind of like inspecting it, I guess. Another good indicator is that we know this is the hypotenuse. How do we know that this is the hypotenuse, Anthony? Anthony would be like, wait, what? And then he'd be like, oh, well, it's because of what you said last time. We'd be like, nice, Anthony, crushing it. Anyway, the way we know this is the hypotenuse is because this is the longest length, okay? And that was one of the big keys I hit on in the last lesson, is that the longest length of the three triangles is gonna be our hypotenuse. So we'll start by labeling this HYP for hypotenuse. Okay, now the next big thing to understand here is that on the notes, we have the angle theta. The angle theta is right here. So all the establishing the angles there, that just helps us orient with which of these is going to be adjacent and which is going to be opposite, okay? So when I have the angle here and I go straight across from it, that's our opposite angle, okay? So opposite is going to be down here, OPP. And this makes sense because the adjacent angle is going to be the line that makes the angle that is not the hypotenuse, okay? So this is the hypotenuse, the other line that makes the angle is adjacent, okay? So we've defined hypotenuse, adjacent, and opposite. So we are good to go, we're in good shape. Now what we want to do is we want to establish what each of the different ratios are, okay? So over here I'm going to be looking for sine of theta, cosine of theta, and tangent of theta. And we're going to write these as ratios, basically as fractions, okay? So again, we want to remember as we're going in here, sine is opposite over adjacent. Sine is opposite over hypotenuse. I misspoke. Cosine is ca, adjacent over hypotenuse. Tangent is toa, opposite over adjacent. It's kind of like oa. Oa is in 7th period. Okay, so sine being opposite over hypotenuse, all I'm going to do is I'm going to write opposite over hypotenuse. Okay, so 24 divided by 26. So op over hypotenuse is 24 over 26. And we want to leave it as a fraction. That's important. We're going to leave it as a fraction for now. Okay, and then in our next couple of lessons, we're going to go into what this actually kind of means for real life applications. Okay, so there's one of our answers. Now we're going to find cosine. Well, cosine is adjacent over hypotenuse. So I can go ADJ over hypotenuse. So I'm going to find the adjacent side length, that's 10. The hypotenuse is still 26. So I can go 10 divided by 26. And that is our cosine of the angle theta. So then our last one is tangent, and that's opposite over adjacent. So I'm going to go OPP over ADJ. Opposite over adjacent, our opposite side length is 24. Our adjacent side length is 10. And that's how we figure out the tangent of the angle theta. Okay, so now we have all three ratios. And this is all we're doing today, guys, is we're establishing what the ratios are. And we're visualizing it with the triangle. A lot of this is just, you're kind of just working through in your head how best to visualize this for yourself personally. Okay, because I know the different things work for different people. What's the phrase? Different strokes for different folks. I feel like I'm 50 years old saying that. Just aged me instantly. Okay, so I will leave that up there for now, and we've got room on the right side of the board, so we'll do our next example kind of down here. Okay, so that was, we'll say this was example 1, and now we'll do example 2. We'll do it down here. Okay, so our next example, we've got a triangle that looks like this. And so one thing, if you guys are like a little confused, we have like A, B, C, but I'm not really worried about labeling these just because I don't think we need to add any more confusion here, okay? So I'm not gonna actually give those labels. They're not actually super important for what we're doing today, but we will try to make this sort of, okay, that looks better already. So I've got a 3 here, I've got a 4 here, and I've got a 5 here. Okay, so the hypotenuse is the biggest number. 5 is the biggest number, which means that this is our hypotenuse. Okay, which means our right angle is right here. Awesome. So now on my note sheet, we've established that the angle theta is here. And establishing it here means that it's different than like in this example when we established it up here. Opposite was here, adjacent was here, now they're gonna flip-flop, okay? So because I've got the angle here, opposite is now gonna be straight across from the angle. So I see that angle and I just keep going out, and this is our opposite. Our adjacent line is gonna be the line that helps make the angle with the hypotenuse, so it's right here, adjacent. Okay, so notice between the two examples, the hypotenuse is always the longest one. That stays the same. It's across from the right angle. But because we switched where theta is, in the first example it was up here, so opposite was here and adjacent was here. Now we moved theta. We just moved it from here to this corner on example 2. So now because theta is here, opposite is going to be this one, and adjacent is going to be this one. That's really the only key difference here with visualizing this question, okay? So now for here, we're going to go sine, cosine, and tangent of the angle theta. And if you guys are wondering like, why theta? Theta is just, these are like Greek symbols, and like if you go on and you take engineering classes, or even if you take my intro to stats class, a lot of times you just use Greek symbols because, I don't know, it's a really good question, honestly, why you use Greek symbols. But the angle theta is just something worth getting used to because this is just what is used for angles a lot in the rest of high school and in college, okay? So just get used to it, it's a Greek symbol. So sine of theta, let's go back over here. Sine is opposite over hypotenuse. So opposite over hypotenuse, 3 over 5. So 3 over 5. Okay, and again, that's because 3 was our opposite angle, 5 is our hypotenuse. So 3 over 5. Cosine of theta, the ratio here is going to be, for cosine, it's adjacent over hypotenuse. So cosine, and again, I'm just getting these from going back up here. Sine was opposite over hypotenuse, cosine is adjacent over hypotenuse. Okay, so adjacent is 4, and our hypotenuse is still 5. Okay, so I just did adjacent divided by hypotenuse, 4 divided by 5. And again, keep them in fraction form. Okay, now tangent of theta. Tangent of theta, this is our opposite over adjacent, right? So opposite is going to be 3 divided by adjacent, which is 4. 3 over 4. And we're done, you guys. This is all pretty easy. You almost don't really need to box it up. We kind of boxed it up differently between the two examples. But yeah, okay, so we've got a few more, and we're going to kind of go a little next level with this stuff. So if you want to take a break now, pause the video, go grab yourself a snack, do what you got to do, and then come back to it, because now we're going to add just a little twist, but it's really, we're not going to be doing anything different. And the little twist is that instead of numbers, we're going to put in a variable but we're still going to define the ratios in the exact same way, okay? So that was example 1, example 2. So again, let's go back, and just like I like to do in class, I'm going to draw like a little key thing up here. Let's see if we can see the left side of the board in the video. It's okay. Yeah, we can use that. So sine SOH, so opposite over hypotenuse. And I'm just going to refer back to this throughout the rest of the lesson, okay? So then cosine CAH adjacent over hypotenuse, and then tangent TOA, TOA, opposite over adjacent. I really wish this was in class so I could just regularly make fun of OA. Be like, SOHCAHTOA. TOA. Pay attention, SOHCAHTOA. Okay, so I'm going to be doing this example in the upper left. Upper left example, we'll say this is example 3. Okay, and we'll draw this triangle out. I have 12, I have 13, and I have a right angle thing here. Okay, so the original rule about defining the hypotenuse, we don't know for sure that this is the longest one because we don't know what this length is, but we do know that it has to be the longest one because it has to be the hypotenuse because it's across from the right angle. It's across from this square, okay? So I'll start off by just labeling this HYP. That's our hypotenuse. Okay, so now the next thing to identify here is where the angle theta is. And the angle theta is right here. So I'm going to put the angle theta down here. And then one extra thing we're going to do here, because I don't know what this side length was, if we wanted to, we could go back to the previous unit and we could solve this, okay? We could use the Pythagorean theorem where we did leg squared plus leg squared equals hypotenuse squared. We're not actually going to go through that, but I just want you guys to be thinking like, oh yeah, I remember that. I could figure that out. We would do 13 squared minus 12 squared. We would get some leg length, the second power, square root of both sides, and that would give us what we get right here. But we're not going to be too worried about that right now. We just want to think about the ratios and the things that we've been talking about so far in this lesson, okay? So what I'm going to do, instead of solving it, I'm just going to leave it as a variable x. Okay, so now we have hypotenuse. The other two things we need are opposite and adjacent, okay? So if my angle theta is right here, the opposite of the angle theta, you just go across from the angle, okay? You just go from the angle and you're sort of drawing a line straight out. This is opposite, which means that adjacent is going to be down here. And that is adjacent, that's just the other line right next to the angle theta that kind of with the hypotenuse makes the angle, okay? So this is adjacent down here. Okay, so I will erase this to avoid confusion. And now we're going to do the same thing. We're just going to define sine, cosine, and tangent as ratios. So sine of theta, that's opposite divided by hypotenuse. OPP over hypotenuse. Okay, OPP is 12, hypotenuse is 13, so this is 12 over 13. All right. Tangent, oops, I got ahead of myself here, cosine of theta. Cosine of theta is adjacent over hypotenuse, ADJ HYP. Okay, so adjacent, I've just given it as the missing variable x, the missing length as a variable x. So adjacent is x, hypotenuse is still 13. X over 13. Okay, and that leaves us with tangent. Tangent of the angle theta equals opposite over adjacent. So 12 is our opposite, x is our adjacent, so opposite over adjacent. That's going to be 12 divided by x. Okay? And so again, you guys, I hope you're not getting too caught up in the terminology here. I hope you're not wondering like, sine, what does that mean? Cosine, what does that mean? Tangent, what the heck is that? I hope you're more just trying to do your best to understand that each of those different functions has to do with a ratio. That's all you really need to think about. SOHCAHTOA. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. That's all we're thinking about here, okay? So we're good here. This was example 3 in the upper left of the backside of your 10A part 2 notes. So now we're going to do this one that's on the right side, okay? So I'll draw this. Again, we'll kind of say that that was our example 3. This will be example 4. Okay, make sure we're still looking good. We're about 20 minutes in. Yeah, this lesson's not too long, you guys, so I think we should be okay, and we can see that mostly well. If you have any questions, or if I'm writing too small, if you want me to write bigger, again, leave a comment in any of the videos, and I'm happy to kind of zoom in a little bit, make it easier for you guys to see. Okay, so example 4, speaking of which, I will do example 4 a little bit bigger. Okay, so I have my right angle is here, the hypotenuse is here, I've got a side length 8 and a missing side length x. Okay, and we don't even care, we don't necessarily need to know exactly what x is, we're just defining the ratios, given that the angle theta is up there, okay? So the first one we know, regardless of where theta is we know that this is the hypotenuse right here, okay? So this is HYP, hypotenuse. Okay, if that's the angle theta, in order to get opposite, I'm going straight across. I'm going straight opposite from the angle. That's going to be x. X is now our opposite. Okay, which leaves the adjacent side length. The adjacent side length is this one right here. Okay, it's right next to the angle, and it's not the hypotenuse. That makes it adjacent, ADJ. Okay, so we're in good shape here. Now we're just going to define sine, cosine, and tangent. So sine of theta, again, I'm going back over here. I'm thinking sine of theta is opposite over hypotenuse. This is just right on the front of your note sheet one more time. I'll show it up there. So opposite over hypotenuse. Opposite is x. Hypotenuse is, let's write a little bigger. Hypotenuse is 10. Okay, so x over 10. All right, now on to cosine. Cosine of theta. And let's give ourselves a little more room here. Cosine of theta is adjacent over hypotenuse. Adjacent is 8. Hypotenuse is 10. Let's box these answers off. Okay, so the ratio for cosine of the angle theta is 8 over 10. Tangent of the angle theta, well, that's opposite over adjacent. So our opposite is x, and our adjacent is 8. So x over 8. Okay, I think that looks pretty good. And really the idea here, you guys, is when you're dealing with angles, like the side lengths themselves don't really matter. It's the side length ratios that do matter for helping you figure out what angles are, okay? Like if you imagine that I just made this triangle bigger, but I kept all the angles the same, the ratios between all the side lengths would stay the same. That's what's important about doing these kind of problems, all right? Okay, so we've got 2 more. We're gonna do these last 2, and we're actually gonna have to kind of come up with our triangle, and we're gonna have to think a little more critically with this one, which is okay, because at the end of the day, that's what we wanna be doing, right? We wanna be thinking critically, learning good critical thinking skills, making our brains work in a way that maybe they haven't had to work before. Okay, so we've just got these 2 more examples. They shouldn't take more than maybe 5 minutes each, and then we'll be done. Again, pause the video, take a break at any point, and then, resume at your own leisure. Okay, so example 5. And example 5 is going to be what we're doing down here. We can also use the ratios given to find other trig ratios. Okay, so what is given is cosine of theta is 7 over 9. So essentially here we've been given 2 side lengths, and there's going to be one that is just kind of missing, and that's okay. So what we can do here is we can kind of back solve to see which is going to be like opposite, adjacent, hypotenuse. Okay, so we know that cosine of theta is adjacent over hypotenuse. So I can just say that this is adjacent over hypotenuse. Okay, so right now I've defined that for the angle theta, the side length adjacent to it is going to be 7 and the hypotenuse is going to be 9. So I can just write any triangle out now and we'll just kind of go from there. Okay, so I'm going to draw a triangle out. I'm going to write the right angle is going to be down here. And because the right angle is here, the hypotenuse will be here. So this is where I'm going to put 9 for my hypotenuse. So 9 hypotenuse. Okay. So now depending on where I put the angle theta is going to depend on where I put 7, or I guess I should say wherever I put 7, it depends on how I define the angle theta. So I'm going to put theta up here, and I'm just picking that. I could put it here if I wanted to. It's just going to flip-flop where we put our side length. So let's put theta up here, which means that 7, the adjacent side length, has to be next to that angle. It's got to be the line that helps the hypotenuse make that angle, okay? So 7 is going to be here, and it's going to be adjacent, which means that we're left with a missing side length here. And again, if we wanted to go back and use our Pythagorean theorem, we could figure it out because we have 2 numbers, so we can find the third one. But we're not too worried about that. We're just going to leave this as a variable x, and this will be our opposite. This will be our opposite side length, okay? So we have cosine of theta. Now we want to find sine of theta and tangent of theta. That's what the problem is asking for here, okay? So sine of theta well, I know that sine of theta is opposite over hypotenuse, and I have defined opposite as x, okay? So it's going to be x over, the hypotenuse is 9 here, okay? So x over 9. All right, so we're good. We've got half our answer. And I say half our answer because the other half is going to come from trying to find tangent of theta. That's the last thing that is asked here. We can find tangent of theta equals, well, that's opposite over adjacent. So again, opposite is x over adjacent is 7. Okay, so we're done with this example, but we're going to get a little crazy here for a second. And we're going to do 2 things. Actually, no, let's just do one thing for this one, and then in the next example, we'll do the other thing. Okay, so I'm going to show you guys that even if I were to switch where I put the angle theta, all that would do is it would flip how we define the side lengths, okay? And it's still going to work out the same exact way. So let's use a different color real quick. Let's go to green. Okay, and let's say that I decided I'm going to put theta down here instead. I can't put theta here because that's our right angle. Putting theta there, it doesn't give us, like, that's not going to be helpful. It's just going to screw up the whole problem, okay? So let's imagine that I put theta here instead. So if I put theta right here, then going back to what we originally talked about, with 7 being adjacent, that would mean that 7 would now have to be down here. So 7 would be adjacent, and then opposite would be across, and again, that would be the one we don't know. So this would be x, and it would be our opposite angle. Okay, but now let's go through the problem. Let's see that we're going to get the exact same answers, because when I talk about sine of theta, I'm like, all right, opposite over hypotenuse. Well, I've defined opposite is still x, hypotenuse is still 9, so x over 9, it's the same. It works, okay? Tangent of theta, again, because I've defined theta as here, tangent is opposite over adjacent. It's still opposite, which is x, over adjacent, which is 7, x over 7, okay? So no matter how you define your angle theta, no matter where you put it, that's going to kind of dictate how you fill in the side lengths of the triangle, okay? So that's the first thing to just kind of keep in mind here, you guys. There's always a lot of different ways to do these kind of problems. These ones are a little more straightforward, but no matter how you decided to define your angle theta, where you decided to put it, you're still going to get the right answers as long as you have your principles for the ratios correct. As long as you're good on those, you're going to be in good shape. Okay, so now we're going to do the very last example. And what we're going to do here is we're going to go through, we're actually going to find the missing side length, okay? Because again, we have it just as x here, but we're going to do it 2 ways. We're going to do all the ratios with x as just a variable x, and then we'll find the missing side length going back to our previous lesson, and then we're going to plug it in and we're going to get the ratios of actual numbers throughout, okay? So all we're given here for example 6 This is the very last example, and all we are given here is tangent of theta. If you can see that, is it focused? Kind of, maybe. Tangent theta is 5/12, okay? So all we're given is tangent theta equals 5/12. Okay, so given that, which of these am I going to use? Not that one. Not going to use that one. Tangent of theta, that's what we're talking about. Tangent of theta. So that's opposite over adjacent. So opposite over adjacent. Okay, so we've already defined our two angles, or our two of our side lengths based on where we put theta, okay? So let's just draw a triangle now here. Any triangle, doesn't really necessarily matter how it looks. The triangles are not often drawn perfectly to scale. Okay, and so because we're only dealing with right triangles, that's what this whole entire unit's about, is right triangles, I know that my hypotenuse is going to be here. Okay, and again, we can define theta wherever we want to define theta. Let's put it down here. Okay, that will dictate what the two side lengths are, putting it down here. So I know that 5 is opposite of theta. So opposite of theta is going to be out here, that's going to be 5. This is our opposite. Well, that means that we're left with adjacent is 12, and that's going to be down here. 12 ADJ adjacent, okay? So our missing side length here is the hypotenuse, that's going to be x. Okay, perfect. So now all we need to do is we need to find sine of theta as a ratio and cosine of theta as a ratio. So my sine of theta, is opposite over hypotenuse, okay? So opposite is here, that's 5 over hypotenuse. That's our undefined variable, or I guess we've defined it. That's our, we don't have a number for it, that's our variable x, okay? We're going to get a number for it at the end of the example, and we're going to rewrite these, but for now, we'll just leave it as x, okay? So now our last one we have to find is cosine of theta. And I go back over here to our little key. Our cosine is adjacent over hypotenuse. So adjacent, that's right here, that's 12. 12 over x. Okay, so these are our answers, assuming that we just keep this as a variable x and we don't actually solve for what that variable is. But we're actually going to go through that. That's going to be the extra little part we do here. So we'll kind of leave these as these are good answers. And now in green, let's go through and let's actually find what x is going to be. Okay, so we'll go back to our Pythagorean theorem that we learned in the last lesson. The leg squared plus leg squared equals hypotenuse squared. Okay, so we know that this is our hypotenuse, which means this is a leg and this is a leg. So I can solve for x now. I can do 5 squared, okay, because that's our first leg, 5 to the second power, plus 12 to the second power equals, well, I've defined my hypotenuse as just a variable x, okay, so x to the second power. Okay, so 5 to the second power is 25. 12 to the second power is 144. So 25 plus 144 is 169, okay? And this is going to be equal to x squared, so this is 169 equals x squared. Now to get x as a variable by itself, I take the square root of both sides. Square root of both sides, and I'm pretty sure this is 13. Let me just double check. The square root of 169 is in fact 13. Awesome. Okay, so I've got 13 equals, and again, the second power and the square root, those cancel, so now 13 equals x. Okay, so what we've just done here is we've found that the hypotenuse is actually equal to 13. So now we can redo these. So we're not going to change tangent because tangent has nothing to do with the hypotenuse. Tangent is still 5 over 12. That doesn't change. What does change here is that now, you know what, let's actually stay in green. Because now with our solved hypotenuse length, we can redo sine and cosine. We can say that sine of theta equals, instead of 5 over x, now we have a number for x. So we're going to say 5 over 12. Or I'm sorry, it's not 5 over 12. That's incorrect. We decided x is 13, so it's 5 over 13. Okay, cosine of theta. Well, cosine of theta, we keep the same thing, 12 over x, X is now 13, so cosine of theta is going to be 12 over 13. Okay, so both of these are correct, and we're in good shape. Okay, so I know that this is like a really brand new concept for a lot of you guys. Let's just double check where we're at in the video. 35 minutes, that's not bad, okay? So this is one where if you're like super confused and it's just you're struggling a lot, then definitely like email me, reach out, any questions you have if you want me to go over in a little more detail. Another thing that I'll probably do is I will connect a Khan Academy video to my, somewhere in Canvas, like where this stuff is gonna be. Just because a lot of this is so confusing, and maybe hearing it from someone else, you can kind of put the pieces together a little bit better. But again, any questions you have, if you want to send me an email, send me like, I don't know, there's ways to do like video conferencing, I'm sure, and I can try to help you guys out. But again, just keep in mind, this is all about ratios. It's all about defining where the angle is, kind of opposite, adjacent, hypotenuse. So we're just looking at this all in the big picture kind of way, okay? So I hope that this made sense to most of you. If not, again, reach out, and I will see you in the next video.